So here we shall give some more examples of on the properties of inverse trigonometric functions. So suppose it is asked to find the value of cos of sec inverse x plus cosec inverse x, where mod x is greater than or equal to 1. So we know that sec inverse x plus cos inverse plus cosec inverse x, when mod x is greater than or equal to 1, that is pi by 2. So we have to find simply the cos of pi by 2, that is equal to 0. So 0 is answer. Then suppose if it is asked, find the value of sine inverse of sine 3 pi by 5. So the rule is that we know that sine inverse of sine x, that is equal to x if x is in the if x lies in the principal value branch, means if x is greater than or equal to minus pi by 2 and less than or equal to pi by 2, then only we can say that sine inverse sine x is x. Now here the value which is 3 pi by 5, that is equal to actually 0.6 pi, which is greater than 0.5 pi. It means what? 3 pi by 5 is greater than pi by 2. So it means that 3 pi by 5, the value does not belong to the closed interval minus pi by 2 to pi by 2. Sorry, 3 pi by 5 does not belong to the interval minus pi by 2 to pi by 2. So therefore, we need to include some value within this principal value branch. So now therefore is sine 3 pi by 5, that we know that sine theta, that is equal to sine pi minus theta. So therefore we can say sine 3 pi by 5 equal to sine of pi minus 3 pi by 5. So that will be equal to sine 2 pi by 5. Sine 2 pi by 5. Now 2 pi by 5, this value is 0.4 pi. So that is less than 0.5 pi. So it means that this value lies within the principal value branch of sine inverse function. So therefore, sine inverse of sine, so it means that 2 pi by 5, this value belongs to the closed interval minus pi by 2 to pi by 2. So therefore, sine inverse of sine 3 pi by 5, that is equal to sine inverse of sine 2 pi by 5 also. So that is equal to 2 pi by 5. So this is the final answer. And then one more example we can solve, that is to show that sine inverse of 3 by 5 minus sine inverse of 8 by 17, that is equal to cos inverse of 84 by 85. So now here let sine inverse of 3 by 5, that is equal to x, and we take sine inverse of 8 by 17, that is equal to y. So now therefore cos of x minus y, we know that is equal to cos x cos y plus sin x sin y. So therefore from here we can say that sin x is equal to 3 by 5 and sin y, that is equal to 8 by 17. And so then it means that cos x, that will be equal to square root of 1 minus sine square x. So that will be equal to 1 minus 9 by 25. That is equal to 16 by square root of 16 by 25. That is equal to 4 by 5. And then cos y, that will be equal to square root of 1 minus sine square y. That is equal to square root of 1 minus 8 square. That is 64 by 289. So that is 225. So it is 15 by 17. So therefore this will be 15 by 17 into 4 by 5, plus this will be 3 by 5 into 8 by 17. So this will be 17 5s is 85, and this will be 15 4 the 60 plus 3 8 the 24. So this is 84 by 85. So now therefore x minus y, that can be written as cos inverse of 84 by 85. Since y cos x minus y is coming 84 by 85. So therefore I can say x is sine inverse of 3 by 5 minus y is sine inverse of 8 by 17. So that is equal to cos inverse of 84 by 85. So hence proved. So then one more example we can solve is, suppose if it is asked to solve the inverse trigonometric equation, that is tan inverse of, sorry, suppose if it is asked to solve tan inverse of 2x plus tan inverse 3x, that is equal to pi by 4. So therefore we can write tan inverse of, since we know that tan inverse of x minus tan inverse of y plus tan inverse of y, that is equal to tan inverse of x plus y by 1 minus xy. So this means that we can do so this will be tan inverse of 2x plus 3x by 1 minus 6x square, that is equal to pi by 4. So therefore we can say that tan inverse of 5x by 1 minus 6x square, that is equal to pi by 4. So then if we apply tan on both sides, so we know that tan of tan inverse x, that is equal to x, and cos of cos inverse x, that is equal to x. So some trigonometric function into its inverse, that will be equal to that x. So therefore we can say that tan inverse so 5x by 1 minus 6x square, that is equal to tan pi by 4, which is equal to 1. So now therefore we can say 5x by 1 minus 6x square, that is equal to 1. So therefore 5x will be equal to 1 minus 6x square. So therefore we can write 6x square plus 5x minus 1, that is equal to 0. It means that 6x square plus 6x minus x minus 1, that is equal to 0. So then we can take 6x common. So this will be 6x into x minus x plus 1 minus 1 into x plus 1, that is equal to 0. So therefore we can say 6x minus 1 into x plus 1, that is equal to 0. So therefore x will be equal to minus 1 and x will be equal to 1 by 6. So these two are the required. So now x equal to minus 1, if we put it here, then so for x equal to minus 1, we will get the left hand side will be tan inverse of minus 2 plus tan inverse of minus 3. So this will be minus of tan inverse 2 plus tan inverse 3. So this will not, so this will be minus of tan inverse 2 plus 3, 5 by 1 minus 6. That is equal to, so minus of tan inverse 2 plus 3, 2 plus tan inverse 3. So this will have some positive value. This will also have some positive angle. So this will not become, so this answer will become less than 0 only. So it can't come pi by 4. Therefore, x equal to minus 1 will not satisfy the equation. Will not satisfy the equation. So therefore, x equal to 1 by 6 is the required solution of the given inverse trigonometric e equation. So this is the final answer. Thank you.